Welcome to the Explainer. Today we're tackling a big one, Docker. You've probably heard the name because this tool has, well, it's completely changed the game for anyone building software. So let's jump right in.
All right, let's start with a classic. Every developer, and I mean every developer, has lived this nightmare. You build something amazing, it works flawlessly on your machine, but the second you try to run it somewhere else, total disaster. It just breaks. So what's going on here? Why does this happen over and over again?
The root of this chaos is something we call the dependency dilemma. Imagine you have two different apps on the same computer. App A needs, say, version 15 of a certain tool, but App B needs version 16 of the exact same tool. Ugh, they can't both be right. This clash creates all sorts of errors and headaches. And it's not just about one or two tools, it's this whole web of libraries and other software that your application depends on to run.
So the whole industry was asking this question. There had to be a better way to make sure software just works, no matter where you put it. And the big idea, the breakthrough, actually came from the real world. Think about a shipping container on a cargo ship. It doesn't matter if it's full of bananas or car parts, the container itself is a standard size, a standard box. And that's exactly what software needed, a universal box.
And that idea of a universal box is really the heart of Docker. So before we get into the tool called Docker, let's talk about the concept it's famous for, containers.
So what is a container? Well, it's that standardized package we were just talking about. It's a neat, tidy little box that has your application's code, sure, but it also has every single thing that code needs to run. All the libraries, all the tools, all the settings, everything is packed right inside. The result? The app will run exactly the same every single time, no matter where you ship that box.
Now, you might be thinking, isn't this just a virtual machine? And that's a great question, but they're actually pretty different. A VM, or virtual machine, is like building a whole new computer inside your computer. It has its own entire operating system, which makes it really big and, honestly, kind of slow. We're talking minutes to start up. Containers, on the other hand, they're way smarter. They share the host computer's operating system core. So instead of being a whole new computer, they're more like super isolated, lightweight apps, and they can start up in a matter of seconds. Huge difference.
So let's bring it all together. Why are containers such a big deal? Well, for one, they're lightweight, so you can cram a bunch of them onto one server. They're totally isolated, so our two apps with conflicting needs, they can now live next to each other in perfect harmony. And most importantly, they're portable. That whole "it works on my machine" problem, gone. For good.
Okay, so here's a fun fact. The basic idea of containers wasn't actually new. It had been floating around in the tech world for a while, but it was, let's just say, not very user-friendly. It was complicated, and that's where Docker enters the story. Docker took this incredibly powerful but tricky technology and made it simple, accessible, and easy for pretty much everyone to use.
So what is Docker, officially? It's an open-source platform designed to make building, shipping, and running containers an absolute breeze. It gives you all the tools you need to manage the whole process, from start to finish. You can think of containerization as the engine, and Docker is the sleek, easy-to-use dashboard that lets you drive.
So how does it actually work under the hood? It's pretty cool, actually. You, the user, type commands into something called the Docker client. Those commands get sent to the Docker daemon, which you can think of as the brains of the operation. It's this background service that does all the real work, building, running, and managing everything. And if you need a specific piece of software, like a database, the daemon can just go and grab a pre-made container image from a place like Docker Hub. It's basically an app store for developers.
Okay, that's the big picture. But what does a developer actually do? Let's walk through the day-to-day life cycle, and you'll see how we go from just a plain text file all the way to a running app.
Everything starts with a file called, you guessed it, a Docker file. That's Docker and file as one word. Think of it as a recipe for your application's environment. It's just a simple text file where you write out the steps. Stuff like, hey, start with this version of Linux. Then, copy my code into this folder. And finally, when you start up, run this command. Super simple, step-by-step instructions.
So you've got your recipe, the Docker file. Now you run a command, docker build. This command reads your recipe and bakes it into something called a Docker image. An image is like a snapshot, a perfect, unchangeable template of your application and everything it needs. But here's the really clever part. Docker builds these images in layers. So if you change just one little thing in your code, it doesn't have to rebuild the whole thing from scratch. It just rebuilds that one tiny layer, which makes the whole process incredibly fast.
And then, this is the magic moment. You take that image you just built and you type docker run, and boom, that command instantly creates a container. A container is the live running version of your application. It's your code, humming along, perfectly isolated, and behaving exactly like you told it to in the Docker file. And you can spin up 1, 10, or 1,000 of these identical containers from that single image, all in seconds.
So let's just recap that core workflow because it's super important. 1, you write a Docker file, your recipe. 2, you build that recipe into a portable image. And 3, you run that image to launch your container. Write, build, run. That's the cycle. It's simple, it's reliable, and it's incredibly powerful.
Okay, so Docker is amazing for packaging and running individual applications. But what happens when things get really big? What if you're not running one app, but dozens or even hundreds of them, all working together across a whole bunch of different servers? Well, that's when you run into a whole new set of problems.
And this brings us to a really important point. Just because you put your app in a container, does that mean you're ready for the big leagues? What happens when you have to manage all those containers at a massive scale?
The truth is, Docker on its own isn't really built for that huge scale. For example, what happens if one of your containers crashes? Docker won't automatically restart it for you. What if you get a huge surge in users? Docker can't just magically create more containers to handle the load. And what if the whole server it's running on goes down? Well, then everything goes down. It has a single point of failure.
And to solve these problems, a whole new type of tool was created called a container orchestrator. You've probably heard of the most famous one, Kubernetes. These tools are like the conductors of an orchestra. They manage huge fleets of containers spread across many, many machines, and they handle all that complicated stuff, like scaling up, healing crashed containers, and connecting them all together automatically.
So, let's circle back. Docker is the tool that gives you that universal box. It's the standard, reliable way to pack up your code and run it anywhere, guaranteed. It solved that awful "it works on my machine" problem and really paved the way for how we build modern software today. It was a total game changer. So now that you have this incredible power, what are you going to build?